Okay. So let me calibrate this here. Let's take a look at your handout. For figures displayed on a grid, there is a simple method for finding the area. The next several exercises will guide you to finding that method. So let's look at this problem here. On your dot array below, make a figure that touches exactly 5 array points and has no array points inside the figure. Find the area of that figure. Construct another such figure and determine its area. This is kind of self-explanatory. Follow these rules and construct some type of enclosed shape and then calculate its area. On your dot array above, make a figure that touches exactly 6 array points. Okay, that's pretty self-explanatory. So now let's go to 31. Make a conjecture. What is a conjecture? Pardon me? What is a conjecture? Who can tell me what a conjecture is? Raise your hand or just say it. This class is pretty informal. Is it kind of like a conclusion? That's a wonderful guess. It's not a conclusion. A conjecture is actually like a hypothesis or a guess. So I conject. My conjecture was that there were 3 sheets, but my conjecture was wrong. There were 4 sheets here, right? So a conjecture is an estimation or a guess. So on 31, you need to make a conjecture relating the area of a polygon to the number of points on the boundary when there are no points in the interior of the polygon. Who here can tell me what a polygon is? A shape with 5 sides? Oh, there you go. That's a pentagon.
It just has to have more than 2, right?
This is a hexagon. It has to have more than 2 sides?
Yeah.
Like a triangle? Yeah, that's correct. A polygon is a shape with more sides than 3. 3 or more. So here's another polygon. Here's another polygon. This is the 3-gon, a 4-gon, 5-gon, 6-gon. What would be an n-gon such that we take the limit as n approaches infinity? A polygon with infinite many sides. Nope. Because it has to close up on itself, right? Aha! You're right. An infinite legged polygon shape creates a circle. Matter of fact, one of the first ways that mathematicians approximated the mathematical ratio pi was they created more and more number of n-gons inside of a circle, right? And they wanted to calculate what is the perimeter of a circle. We already know it's the circumference, right? 2 pi r. But before, humanity didn't know this truth. And when this truth was being discovered, the way they approximated the circumference of a circle was they first tried to approximate it with the perimeter of this hexagon, then a heptagon, then an octagon. I like octagons. And then you keep doing that, and if you get enough shapes, then you get closer and closer to the perimeter value, or the circumference, if you will, of a circle. Really cool, isn't it? Why are y'all laughing? I'm glad that you guys are enjoying yourselves. This is supposed to be a fun class, right? So it's okay that you're laughing. As long as you're not laughing at me or making fun of me. As long as you're not making fun of me. Okay? So we make a conjecture. We check our conjectures for polygons 8, 9, and 10 boundary points, no interior points. Now make a polygon with 5 points on the boundary and 1 point on the inside. So follow these rules here, and I'll come around and make sure that you're staying on task and doing it appropriately. So let's go to that last. So let's go to 38, actually. Let's go to 38. 38 says, make a conjecture about a formula that gives the area of any region in terms of the number of points on the boundary and the number of points inside the polygon. Verify your formula by making 3 new polygons and using your formula to find the area of each. Show that each polygon on the dot array in your calculations. So you guys are going to discover a theorem. Your formula should be a theorem called Pick's theorem. So you guys are doing what mathematicians do. You are inventing formulas. You're looking at mathematical phenomena. You're seeing trends within the mathematical phenomena, and then you're going to create a formula. Okay? This is really cool. This is what mathematicians do all the time. And the last page is use Pick's theorem to find the areas of the following regions. So you can see if your Pick's theorem is correct by using the enclosure or the method of partition. Any of those methods will be ways to check yourself. All right? Get started while I pass out your previously graded assignments. Eden Holetsky. Eden, Hope, Perry, Jordan, Harrell. Jordan. Oh, Scotland. That looks like a W. What's an S-O-T? Scotland. Scotland. Okay. Nikki.
Why are y'all laughing?
Trying to memorize you guys' name. Emma, Offer, Noah, Abrego, Manita, Jacobs. Are that you guys? You're Emma and you're Noah. Okay. Yeah, Manita, she let me know she can be here. What was your name again?
No, I'm not gonna be called.
Ramiro? Okay. Ashley Strauss. Ashley. Yahaira. Yahaira. Aubrey, Sawyer, Brianna Matthews,
Right here.
Deja Davis. Deja's the one that's not here yet. Emily Taylor. Emily Taylor. Emily, I'm gonna try and memorize your names.
What is that?
It's gonna take a while. Madeline Grant.
M-O-P.
Oh, Madeline Grant. Madeline.
Yeah, we're nice.
Maddie. Shelby Hutchinson.
That's what I was
Raina. Magallanes. Reina or Raina? Reina. Like a queen. Hannah Westrick. Hannah Westrick. Oh. Hannah Westrick. Hannah. Michaela.
Oh, shoot.
Michaela. Maddie.
Well, I got 22.
Michaela. Lanita, not here. I got some on visitors. Ashley Strauss. Ashley. Asia Davis. Reina. Brianna. You Brianna. Reina. Sorry. Sari. Sari. Reina. Asia. Brianna. Brianna, Deja, Reina, Noah. Noah, over here. Scotland.
Oh, wait, who's
Over
this?
here. You see, this one doesn't.
This was
Scotland.
mine. I got an
The
82.
other one was like that. Where something. Nikki, Lord. Nikki. Emily. Emily. Taylor.
We're three.
Oh, Barry.
I think we all did schedule the
Aubrey Troyer. Aubrey. Jordan. Harrell. Emma. Hoffman. Emma. Hoffman. Emma Hoffman. Shelby Hutchinson. Shelby. Either Shelby. Yaharia. Is that pronounced correct? Yahira.
Homework back. Robbie is 75.
Eden.
Okay, so you know that homework that me, you, and Brandon did together? I don't know, but one of them, we all got different grades.
Aubrey Troyer.
Mine is 30.
Yes, I did. Aubrey. Scotland. Emma, Noah, and
And I chose. That was too much.
Ashley. Hannah was so this is a weird situation here. So you guys, Maddie, which is here, where's Hannah?
I wrote down her instead.
Okay.
Yeah.
Okay. Ashley. Okay. So what you might want to do is come take a picture of this to see like the feedback.
Okay.
Because I don't know how to do this, and then you want to take a picture of that. Hope.
The answer.
Hope. Yahira,
Wait,
Yahira, Eden, and Shelby.
where's my answer? I'm really confused.
This is Shelby. Sari, right? Sari, Brianna, Asia.
Wait, you said Brianna and Deja, right?
Yes, that's, yeah.
Oh.
Yes, ma'am.
Where's my homework go?
Yeah, I wasn't on the front, but it was.
Send me an email about it.
Okay.
Send me an email about it and tell me what assignment it is, so I'll make sure that that happens. Yes, ma'am.
Are they being graded by like each of them? Don't agree with that. They all have different grades.
So, whoever you work with, that group, you all get that same score for each individual.
But not on the homework.
Not on the homework. Homework is supposed to technically work on your own. You can collaborate on the homework if you guys like, but you have to turn in your own assignment for the homework. Each individual has to turn in their own assignment for the homework. There's no like turning in one big homework as a group.
Okay, good. Next time we all.
Nikki, Jordan, Harrell.
Does you want to look it up? Like that.
You guys go. So the keys on the how to do this assignment, all the ones that turned in, I'll upload that on Canvas, so you'll be able to see what you did wrong or whatnot.
Yeah. Well, was it going? Oh, yeah. Okay, let's. I don't know.
Yes.
So is it gonna be something like that?
So let's see. On your dot array, make a figure that touches exactly 5 array points and has no array points inside the figure. Find the area of the figure. There you go. That works. I'm not going to tell you how to find the area though, but I'm going to tell you that that is correct.
I know that.
That's what's up. Yes.
I mean, 25.
Yes. Question?
I don't know what homework that's.
That's something. You turned in.
We forget to take pictures.
So the grader has had some family issues going on. She's let's say been very distracted. So send me an email about that. Chances are she has your work, but hasn't graded it yet. Okay, so make sure to send me an email about that. I'll make sure to go investigate that.
I think for the area of 28, I think you write it like right under here.
5 points.
And your daughter array is gonna have find the area, such figure, and determine it. So 2. I guess we could make something like that.
Check your theory with 8, 9.
So we need to make 2 different figures like this, right?
Well, let's read it. To my 28.
For every.
On your dot array below, make a figure that touches exactly 5 array points and has no array points inside the figure. Find the area of the figure, construct another figure, and determine its area. Let me see what you got.
We need 2 different.
Okay, now, in those figures, is there any dots in the middle of the shape? On your tape?
So, the area, make an area. Exactly, yeah.
Yes, yeah.
Starting on it, I mean, there's one. I just went 5. Okay, I'm gonna say. Just same number of points.
No, you do it on
Let's see. On your dot array below, make a figure that touches exactly 7 array points. Okay, approximately 7. You don't want to in the middle. Find the area of the figure, insert another one, and determine the area of that one. Yes, ma'am. So no dots inside. So something like this one count. Something like this one count. See, so that has dots inside.